Okay, we are now ready to write our first 8086 program. To write 8086 program, first thing that you have to do is you have to open Visual Studio Code. So you type in the search bar Visual Studio Code. This app should appear, and then here you see by default it will not open this folder. Let me close it. Actually, it should look something like this. When you open Visual Studio Code, it should appear something like this. Okay, then from here what you have to do is, as I said in my first part, that whatever the code you write, you'll be writing all the code inside these C TASM 1.4 and TASM folder. So for that reason, what you're going to do from Visual Studio Code is you're going to open that particular folder. So you'll be clicking on file, and then you'll be clicking on open folder, and then you'll go to my computer or PC, and then C drive, and then from there TASM 1.4 and then TASM. Select that particular folder and click on select folder. As soon as you do that, you should see that okay, this particular folder is now loaded in Visual Studio Code. You can say it that way. Okay, and if it looks something like this, what this arrow mark is represents is that if you click here, it will actually expand and it will show you the content of the folder. What are the things there, what are the files and subfolders are there inside the particular folder. Okay, along with that, you should be able to see these icons there, like see these. If I keep my mouse cursor here, you should be able to see that okay, it is showing you a new file. It means if you want to create a new file, then you have to click here. Now see, okay, whenever you are writing your 8086 program, then obviously you have to write it in a different file, in new file. So for that reason, you have to actually create a new file. Okay, I'm clicking here on this plus button. It will, as soon as I click on this plus button, it will, this text box will appear where you can actually type the name of the file. The file name could be basically anything. Say, for example, I'm calling it, say, first 8086 program. Okay, program. So this is my main file name, the main part. But here the main part could be anything. But as I said in my first part, that the extension of 8086 program or 8086 program file must be um, .asm. So I'll be writing this thing .asm. That will indicate okay, this file contains assembly language code. The way, like, you give the extension of C program source file as .c, C++ program source file as .cpp, PHP source file as .php. The same way for 8086 assembly code, assembly source file, you will be giving the extension as .asm. Okay, done. Once you specify the file name, you just click outside. Automatically, that file will be created, and now you're ready to actually write the code here. Okay, now let me write the basic skeleton of 8086 program. The first thing that you'll be specifying is you'll be making use of this model directive model small. Now you might be thinking, what is this? Actually, this has to do with the memory model. There are different memory models that are like tiny, small, huge, I think compact. Different models are there. I'll be discussing about those different models in the coming videos. But for the time being, what you can think of is that whenever you write an assembly program, a 086 assembly program, you always have to write that as the first line of your code. I don't ask you to accept that thing as it is, but for the time being, I'm just asking you that for the time being, you accept the thing as it is. Okay, as we move forward, then certainly I'll be able to explain you these things. Okay, then model small. And here, basically, what am I going to do is I'm going to write the basic skeleton in the sense that for most of the assembly language 8086 programs that you will be writing, this part is not going to change. Okay, anyhow, let me write and finish, then you will automatically come to know. Okay, so the first line that you'll be writing as dot model small, and then after that you'll be writing something as dot data. Okay, and there don't write anything for the time being. Okay, dot stack, and if you write, just write 10h or something. write it as it is. I'll be explaining. Anyhow, if we move for, as I said, no, like if we, this is just the second part of the series. So hold on, automatically things will make sense. And then dot code segment, like here. Now, out of which this stack actually, if you want for the time being, you can omit this part. The two things here, one is the data segment of the program and one is the code segment of the program. And you might be thinking, what is that? Okay, then if it is confusing, even you can eliminate this data segment. There is no data segment in the program, only the code segment there. Let me zoom in a bit, then you'll be able to see it more clearly. Mm, okay, let me write even this data set, although empty, but we will be writing it in. This is the basic skeleton of most of the assembly program that you'll be doing actually. Okay, so for that reason, I'm writing it in this way, stack. And for stack, actually, I have to specify the starting address. So I'm writing here 10H, and then this is the code segment. Now, this code segment contains the actual code or the 8086 code which will be executed. Okay, and here what code will you write actually? Okay, as you know, like 8086, whenever you are writing 8086, whenever you are doing 8086 programming, basically, you have to make use of the 8086 different 8086 instructions, right? So if you know, then there are few, at least a few, very commonly used instructions. Say, for example, move instruction, add instructions. They are very simple, and the name itself indicates like what that instruction might do. Okay, so for that reason, what we'll be doing is same. I'll be showing you one example. I'll be writing here my code in this way, move, and like again, to follow this video series, I'm just assuming that you people know about the registers of 8086 microprocessors, like the different registers, like general purpose register, the four general purpose registers, AX register, BX, CX, and DX, and the index registers, the flag registers, and the segment registers. Those things, at least you should know. But again, if you do not even know them, only heard about them, that will also be enough, actually. I'll be showing you, the things in a moment. Don't worry. So, but again, the minimum thing that I'm assuming is that people know, like, there is something called as a AX register in 8086 processor, or BX register in 8086 processor. And also, I'm assuming like what these move instruction do. I'm assuming a lots of things I know, but then also let's proceed. Once we make the steps, once we make a few steps, then certainly things will become more and more and more clear. So what am I doing here is move. I'm writing here AX, comma, say, I'm writing what I want to write here, say 10H. Okay. Now, what is this 10H is like AX, comma, 10H. This 10 is the number, I mean, the value, and this H represents, okay, this value is in hexadecimal. If I simply write 10, if I simply write 10 there, it will be the decimal 10. Okay. But if I write 10H, it will be the, hexadecimal 10. Right? I mean, again, this is also an assumption that what is a decimal number, what is a hexadecimal number, and all. So anyhow, it will copy 10H. Okay, if this 10H is creating confusion, just I'm writing here 8. Okay, 8 and 8H, both of them are same, because the decimal 8 is same as hexadecimal. I mean, if you convert the decimal 8 to hexadecimal, it will remain 8 only, or up to 9. Everything is same actually. One is same as one decimal is same as one hexadecimal. Two decimal is same as two hexadecimal. That even 9 decimal is same as 9 hexadecimal. But 10 decimal is actually AH, that you know, right? 11 decimal, that is decimal number 11, is actually BH, like that. You have to write a 0, I guess, here. But anyhow, say for simplicity, I'm writing here say 7. Okay, like you can write 7H also, 7 hexadecimal and 7 decimal, both of them are same. So what am I doing here is I'm actually copying 7 as the content of the AX register. That's what this move instruction does actually. Okay, like it copies whatever you write on the right hand side. That will be copied as the value that of the container that you specify on the left hand side. It is a move instruction basic essentially does like the assignment. You know the assignment operator in C programming language. Like here, let me write it here. Let me write it here in this way. Like see, whenever you want to write, if you know C programming, then you write, like say you want to store 3 in a variable. How do? You write a is equal to 3. Say a is the name of the variable. But in 8086 program, if you want to do that, you'll be writing these move instruction. This move instruction basically does these these assignment operator. Whatever this assignment operator whatever this assignment operator does in C programming or any other high level programming language. Okay, so if it is the case, then from here you should be knowing, you should be making a guess, like educated guess that okay, the 7 will be copied as the value of this AX register. Done. And then what am I going to do is I'm going to copy. You might be thinking, what program am I writing? I'm not writing any program. I'm just, uh, you know, okay, again, as I said, now things will make sense in a moment. Just hold on. What am I doing is I'm writing again, I'm trying to store, say, move bx, comma 8h. Okay, then I'm copying 8 to bx register. Done. And after that, now see, these two lines are actually I'm writing as as if they are my these two lines are my actual program. Now once the program you have written, like whatever the program you were about to write, suppose this is your program. Once you finish writing your program, you have to actually tell the computer that okay, now this is the end of the program. And how you're going to do that? For that reason, you need to make use of something called as interrupt. What I mean by that is, see here, whenever you are terminating a 8086 program, you have to write a few lines. For the time being, I'm just saying it that way, okay? And what are those few lines? First thing that you have to do is you have to copy to A8. You have to copy to A8 04CH. Okay, I mean this H is coming from because this 04C is in hexadecimal. Okay, so this particular number you have to copy to AH register, and after that you have to write something called as int 21H. Basically, what it is that it is this int is not the int in C programming language or C++ programming language. This is an instruction basically. See here, interrupt call. It will call a particular set of code based on the value which is there in AH register. In AH register, if you store 04C in hexadecimal, and then after that, if you call this interrupt service routine, then that will tell the computer that okay, now this is the end of this is the time to actually terminate the program. And after that, you have to write end to make the end of the program. Now see here, here I just wrote our first 8086 program, and here what am I trying to do is I'm just trying to write the basic skeleton of the program. Now here model small means, as I said, now different models are there, like tiny model and small model and huge model. I'll be talking about these different models in the upcoming videos, but for the time being, you just assume that okay, for all these programs, whatever you're going to write, at least for a few days, we'll be using this small model. So this line you'll be writing always as it is. Now this data, actually this dot data that represents like uh, you know mm, uh, what are the variables that you want to create in your program. All those variables you'll be writing here, in this data segment. Basically this thing is called as the data segment. This is called like, here by writing the dot stack, basically you like specify okay, from where that stack should start. And now you might be asking like, what is the use of that stack? Yeah, right now we are not going to use it. So if you want, you can actually delete it. That stack might create confusion. But this data and code we'll be using actually from the beginning itself. Although in this program, I have not used any data. So in this program, basically this part is also not needed. But I'm going to use it very soon, so I'm keeping it. And then this is called as the code segment. Now in code segment is the part where you'll be writing your actual program. And when I say actual program, again, you see, all these 8086 programs, you always have to end the program by writing these three lines. What these three lines are doing, as I said now, I already said you about this move instruction. What this move instruction do, what this move instruction does, it copies what, it is an assignment operator basically. So here 4CH, I mean 4C in hexadecimal will be copied as the content of the AH register, and after that we are calling this interrupt, and this now see int21h is written to call an interrupt service routine, and which routine, or which, you can think it of as if like we are calling a function, and the input to the function is specified in AH register. Okay, and so whatever it is, the in based on the input, actually the function behaves differently. So if the value of the AH register is 04C in hexadecimal, then the this int21h will actually call a function that makes the, that terminates the program. Okay, that terminates the process. That's what the meaning of all these things. um, I guess if people at least got some idea, at least some idea about the things what is happening. But if things are not very clear right now, then I'm going to show you now something which will again help you to take your understanding slightly, you can say, to the next level. Okay, okay, then now what is the next thing that I'm going to do? The first thing that obviously you have to do is you have to save this file. So I'm clicking on file, and then actually my autosave mode is on, but then also I'm showing you if it is not on in your case, what you have to do is after writing the code, you have to click on the save button. That our first program is written. Now it is time to see the output. Okay, how we can do that? So for that reason, what you have to do is you have to uh, open the other software that you install, that I asked you people to install in the first part. So here is this. Okay, by default it will open in full screen mode, but I don't want the full screen mode. So for that reason, what you have to do is you have to click on this. You have to press this Windows key from the keyboard. You just press the Windows key. It will exit from. It will exit from the full screen mode. And after that, here is this thing: C:\tasm. Now here you see the first thing that you have to do is you have to compile the program. Here you can see something is written like for compiling some ASM file, say add.asm, what is the command? Command is tasm and the name of the file along with the extension. And that is the first thing that you have to do. The way you, how do you, execute a C program? First thing is that you write the program and then you compile the program. And when you compile, basically, if there is any syntax error in the program, this compilation will process will actually show those errors. Like if there is any error, then compilation will not be completed. The same thing is true here also. Okay then, but first thing is that let's compile the program that we just have written. So for that reason, what we have to do is we have to make use of this command tasm and then the name of the program. And what is the name of the program? The name of the program is first 8086 program ASM. It's quite a long name. So can I copy and paste it there? Let me try. I'm copying it, name of the file, and I'm trying to paste it here. Okay, no, it's not getting pasted. No, I have to type the name of the file. So I'm typing it first, FIRST first, 8086 program .asm. This is how you compile. I see it's showing you cannot locate file first 80. Okay, that's something. I wrote something wrong here. FIRST first 8086 PROGRAM.asm. What mistake I did? Oh, obviously the spelling is wrong. That's why I don't keep such a long name. PROGRAM. That's what I wrote. Mm, Okay, just a second. Let me rename this file. It's too long actually. Rename. So I'm just calling say pp1.asm. Funny, but it will make my task easier. So I'm writing here tasm pp1.asm. Now see, as soon as I write tasm pp1.asm, assembly file pp1.asm, error message none, warning message none, passes 1, remaining memory 476 kilobyte. Okay. Don't worry about this remaining memory part for the time being. Only see that there are no errors in the program. Suppose if I write something wrong here, then those error messages will appear actually. Like say for example, like pp1.asm I'm opening, and then here I'm writing, say, instead of writing move here, I'm writing move as. Okay, is there a command move as a, say something I wrote in that way, and then I'm trying to compile this program. You will be seeing that okay, pp1.asm illegal instruction at line number 7, most probably. It's just giving you some hints. Okay, at line number 7 there is an illegal instruction, that's not a valid instruction, so for that reason that error is coming. Again I corrected the error, and again I'm trying to compile the program, and then the error is gone. Now say once the program is compiled, the next thing you have to do is you have to link the program. Now you might be asking, what is linking? Yeah, I'll be telling you again in the coming videos. But my point here is that I just wanted you people to bring, you people to actually take you to the stage where, you only can concentrate on the logic part, like, of the program, and you can start writing the code. But anyhow, the next step, if you want to execute this 8086 program, the next step is that you have to link the program. Okay, and for that reason, you have to write t-link and then the name of the program. Only the name without the extension. Okay, and that is after compiling the program. Okay, so first you will be compiling the program by writing tasm, the name of the program, along with the extension, and then you'll be linking the program with existing. You'll be linking the program, and that you will be doing with t-link pp1. Okay, I mean the name of the program without extension. Here you can see I didn't write pp1.asm, I just wrote pp1, the name of the program only. And after that, you should be seeing this message. If you're not using any, since I didn't use any stack segment here, that's why that warning is coming. But if I write here, say for example stack and h, that warning message should disappear. But since I changed my code, again I have to start from the beginning. That is, first I have to compile, and then I have to link. Now that warning message is gone. But although I have written here stacked and age, but I'm not making use of that stack, segment actually. But we'll be using it certainly in the coming in the coming videos for some programs. But for this program, certainly we are not using it. Okay, then we want to see, say for example, the output of the program. What output this program will generate? Frankly speaking, this program is not going to generate any output, and generating output was not my main concern. My main concern was to show you something else, and that is very important actually. Now let's see what is that something else that I'm going to show you, and it is the most important part. Okay, you just please concentrate here. And what am I going to show you is that I'm going to show you this program, like I'm going to show you how this program is executed. I mean, line by line, what happens when you execute this line, what happens when you execute this particular line. That way I'm going to show you, that is the thing that I'm going to show you in this video. And that thing is called as, seeing the program in debugging mode. Okay, and if you want to see the program in debugging mode, what you have to do is you have to write td and the name of the program. That's all. td and the name of the program without any extension. If you do that, as soon as you press enter, this window should appear. Program has no symbol table. Okay, that is not a problem. You just click on OK. Done. Now, once you do that, you should see that. Let me make it slightly bit bigger. This is your program. Don't see here. So now see, it might happen that your mouse cursor got stuck in this particular window. So if it is the case, then what you do is you can press actually the Windows key. Okay, as soon as you press the Windows key, your cursor will come out of that that trap. But my point here is, you see, your program in the see here again, the code of your program will be here inside the code segment. That is, after writing this dot code, you'll be writing your actual code of the program. Okay, so you see here, this is your program, and more or less the same thing is appearing here in the debugging mode. You see, this is your first line: move ax comma 007, move ax 7h. Now 7h is same as 7, so 7. Okay, and then again move bx comma 008. You see here, you just compare the right hand side here. Right hand side means this particular window, and here you see ax comma 7h is this line, and bx comma 8h is this line, and then ah comma 4ch is this line, int 21h is this line, and this is the end. And after that there are some instructions, but those instructions are not part of this program. Okay, that's okay, but what else? What else? Now see here in this window, in this blue window, not blue exactly, cyan window, you can see that on the right hand side, these are the registers. You know, like the general purpose registers like AX, BX, CX, DX, those 4 16-bit general purpose registers, these are these registers. And you know, again, as you know, that these registers you can actually address by as a 16. You can use those registers as 16-bit registers or 8-bit registers. So this AX register is actually, it's a combination of two. This 16-bit register is actually a combination of two 8-bit registers. As you know, this is the AH register, and this is the content of the A. Sorry, this is the content of the AH register. This is the content of the AL register. This is, I mean, least significant bit to most significant bit. So these higher order 8 bits are BH register. The lower order 8 bits are BL register. Okay, and the same way for others also. But now, point here is, you see, this is when you execute a 8086 program in debugging mode, then what you can see is that you can see the program you can execute the program line by line, instruction by instruction. So right now you see one thing you should see here. This instruction pointer is having the value 0000. It means in the code segment, inside the code segment, in the memory location 0000, like whatever the instruction it is there in that memory location, that instruction will be executed. I said will be executed. What this instruction pointer points to? Instruction pointer points to the next instruction which is going to be executed. That thing I guess you people know. So in that case, so what right now is the value of the instruction pointer? 0000. I mean, inside the code segment, 0000H, whatever the in that particular memory location, whatever is the instruction, that instruction will be executed. Now see here in this code segment 0000H, this is actually the opcode, but the thing is, this is the instruction which is there in that memory location. It means what? This particular instruction will be executed. I again said will be, but when that will happen, that will happen as soon as I press F7 from my keyboard. You can see here F7 is stressed. I mean, if I press F7, then the current instruction in the sense, if I press F7 from my keyboard, then whatever it is the instruction this IP is pointing to, that particular instruction will be executed. So right now IP is 0000. So at 0000, this instruction is there. So as soon as I press F7 from my keyboard, this instruction will be executed. Okay, if that thing is making sense to you, then you also should realize that at this point the value of the AX register is 0000. As you can see here, the value at this point, that is before executing this command, the value of AX register is 0000. So After executing this command, as we know the behavior of this move instruction, what does this move instruction do? It will copy whatever you write, whatever you specify on the right hand side as the value of the container that you specify on the left hand side. So container in the sense I'm talking about the registers right now. Okay, you can, as I said, no, I already said you that move is nothing but it is the assignment operator equivalent. So what does that mean? That if I press F7, this instruction will be executed. As a result, this 7 will be copied as the content of the AX register. It means immediately as soon as I press F7, the content of this register should change. Right? Okay then. Believe me, I'm pressing this F7 now from my keyboard. 1, 2, 3. I mean 3 here. Okay, now I press F7, and now see, as soon as I press F7, a few things change actually. What is the first thing that changed? Obviously, the content of the AX register changed. That is the first thing. The second thing which is saying changed is this: the value of this IP register. Right now, it is pointing to 0003. I mean, the value of this IP is now 000. Instruction pointer is now 0003. Okay, it means now the next instruction which is going to be executed is whatever it is there in 0003. So in 0003, the instruction is move bx, 0008. It means this is the instruction which will be executed as soon as I press F7 from my keyboard. Okay, understood? If it is, now just think for a moment, like this is the very basics, but this is something you should understand very clearly to write 8086 program, I know, like fluently. Okay. Okay, then now I'm going to press F7 one more time. As soon as I press F7, you just have a keep your eyes here in this BX register. As you predict, okay, as soon as I press F7, this 8 will be copied as the content of the BX register. It means what? This content of this BX register will become 8, 0008. Okay, 1, 2, 3. I pressed F7, and then you can see the content of this BX register is now 8, and then instruction pointer is changed to 6. It means whatever it is there in 6 memory location, that particular instruction will be executed. Now obviously now the next instruction is move AH, 4C. It means 4C will be copied as the content of AH register. Now see here, it is not AX, it is AH. It means which part is AH here? These 8 bits are AH register. So it means if I execute move AH, 4C, it means these 8 bits, these higher order 8 bits will change to 4C, and these lower order 8 bits will remain same. I mean, if they are 07, then they will remain as 07. But these 8 bits, these higher order 8 bits will change from 00 to 4C as soon as I press F7. Right now, see this arrow you should be able to see here. Like this is the instruction which will be executed. I mean, this is the next instruction. I mean, this is the instruction pointed by instruction pointer. Okay, and again, okay, I'll be coming to that point. But now see, I'm going to press F7 as on my like third count, like 1, 2, 3. I pressed F7. You can see that okay, now this is changed to 4C, and instruction pointer is now pointing to the next instruction, which is int21. As I said, no, this int21 will actually call a specific function based on the value, based on the current value of a H register. And if the value of the H register, current value of the H register is 4C, then the routine that will be called when int21 H is executed will be the routine that will actually terminate the which actually terminates the process. Okay, that basically you can say that okay, which ends the program. Okay, now I'm pressing again FC at my third count, like 1, 2, 3. As soon as I press F7, you can see that okay, terminated, exit code 7. You can click on okay. I mean, that is the end of the program. Okay, now from here what we learned basically is that like how to execute a program. First thing is that we learned like the basic skeleton of a 8086 program, like what are the different components which are there when you write a 8086 program. More or less, we learned that thing, and then we also learned like how to execute a 80, how to compile a 8086 program, how to link a 8086 program, and then most importantly, how to execute a 8086 program in debugging mode. And why it is important, like what happens when we execute a 8086 program in debugging mode, we will be we are actually allowed to see or execute the program in line by line, okay, one instruction at a time. That way we should be able to see the changes a particular instruction makes in the content of these different registers. That's what I showed you, okay, in this part. Okay, that much only in this part. In the next video, again, we'll be doing some more examples to concretize our understanding.